Hello everyone, welcome to the channel Top Gate. In this video, we'll see the conversion of language to grammar. So in the previous lecture, we have seen what is a grammar and we have seen the relationship between the language and the grammar. So we'll be getting two kinds of questions. One will be given with a language and this language has to be converted to a grammar. And the second type will be given with a grammar and this grammar has to be converted to a language. So in this video, I'll focus on this first one, that is, will be given with a language and this language has to be converted to a grammar. Okay, so now we know that the language is of two kinds. One is a finite language and one is a infinite language. Clear? So in this video, I'll focus on both the languages. So I'll take case one for the finite language. In this one, I'll give you few examples, and few examples means I'll give you few languages, and for those languages we will design a grammar, and for case two we'll take up infinite languages. In this one again, I'll give you few languages, and for those languages we have to design a equivalent grammar. Okay, so let's start with case number one. Case one is for the finite languages. Okay, so let's suppose the sigma that we have is a comma b. What is sigma? We have already seen in the previous video. Sigma is the input terminals, so the strings that we'll be getting will be in the form of a and b. So only two alphabets we have, a and b, and we have to design all the strings of a and b only. So let's suppose the language that we have is, we have to design all the strings of length 2 over the alphabet AB. So in this one, how many words are possible? Let's see. Since alphabets we have is AB only and every word should be of length exactly 2 only. So the words possible in this case will be AA, second word will be AB, third word BA, and the fourth one will be BB. So only 4 words are possible in this case. So now, since the number of possible words in this language is known, that is why this language is called as a finite language. If the number of words is unknown, that will be called as an infinite language. So this is my finite language, and for this finite language, I have to design a grammar. Okay, so in the previous video, we have seen the most important thing in the grammar is the production rule, and this production rule will be in the format of alpha tends to beta, with alpha and beta being the combination of variables and small letters. So small letters we have is AB, the alphabets, and the variables we'll use as and when required. And in the variables, the most important variable is the start symbol. Like I told you in the previous video, that start symbol acts as, you can say, just to relate with the initial state in the NFA DFA. So we'll start the journey from the start variable only. So any string that has to be generated will be generated from the start symbol only, and then we'll use the variables as and when required. So let's see, in this one we have 4 possible strings. So every string should be generated from the start variable only. So there are several ways of writing a grammar for this language, since it's a finite language. So let's see, the first method of writing the grammar for this language will be S derives. Since the strings are known, so we'll simply write like this: S tends to AA, or S tends to AB, or S tends to BA, or S tends to BB. So this is the grammar for this particular language. So only, this is the first way of representing this grammar. Let's see in other ways how we can represent this. Now, in the language what we have, so what is the regular expression for this one? Now, to write a regular expression, if you analyze this one, we can see that this comma means or here. That means the strings that we are generating is either AA or AB or BA or BB. Clear? So in regular expressions, we know we use plus operator for the or thing. Clear? So regular expression for this one will be AA plus AB plus BA plus BB. So this is the regular expression for this particular strings. Okay, now let's see what we can do in this one. If I take A common from this one, you can see here that we have AA and AB. So this A is common here. So what I'll do, I'll just simply take A common from this one and I'll be left with A plus B. Clear? Again, plus if I take this b common from here, so I'll be left with a plus b. Clear? Again, if you see, we have now two expressions. One is this one is this one. So if I take a plus b common, since a plus b is present in both the expressions, so I can take a plus b common. So if I take a plus b common, what I'll be left with? A plus b. So I'll be left with a plus b. Now, what is the meaning of this a plus b and a plus b? This a plus b means a or b. That is, in the first part of the string, we'll be having a or b. In the second part of the string, we'll be having a or b. Now, there is a difference between the mathematical notations and the notations in this regular expression. Like suppose, if you have 2.3 in mathematics, you will write it as 6. 2 into 3 is equal to 6. But if you write 2.3 in regular expression, then it will be 2, 3. That is, we are concatenating 2 and 3. Clear? Second thing, if you write 2 plus 3 in mathematics, that will be called as 5. And if I write 2 plus 3 in regular expressions, then that means this is OR. That means 2 or 3. So that is the difference here. So what does this a plus b means? That means the string will have two parts. First part, second part, like we have this here. First part, second part, first part, second part. So the first part of the string will be a or b, second part will be a or b. Clear? So this regular expression means these strings only. Now see, if I call this a plus b as a and this a plus b as b, what does a means? A means a or b. So a derives a slash b, a or b. Similarly, what does b means? So b derives a or b. Clear? Now the string contains two parts, a and b. Now I told you that the string should be generated from the start symbol only. So what I'll take here, I'll take s, and s is the combination of a and b. So I'll write a, b here, with a as a or b, with b as a or b. Now let's see how we can derive a particular string. Let's see whether we can derive ba from this one or not. So ba, what I'll do, I'll use this rule. So this is the grammar you can see, and we'll use this grammar to generate any particular string. Now let's derive this particular language ba from this grammar. So what we have b first. So the first rule that I have is I will write s tends to a, b, and then what I want b here. So which rule should I follow? This a, I'll follow this rule. That means I will, in place of this a, I'll put b and then b. Why? I'll write the reason here. What is the reason? A tends to b. That is given here. And then this b, I'll write it as a. So I'll get b a. Why? Because b tends to a. So this way I can generate any particular string of this language, a, b, b, a, or b, b. And these rules can be used to generate this particular language. So this is the equivalent grammar for this language. Okay, so how many ways we have seen? First way to write a grammar is this one. Second way to write a grammar is this one. Now let's see one more way. Since a and b both are same, so a is a or b, b is a or b. So instead of writing this one, what I can write s tends to a, and then I'll derive a tends to a slash b. Clear? Now let's try to derive this particular string bb from this one. So what I'll do, s tends to a I'll write. Now what I want, bb. So in place of this a, I'll put b a, and then again b b. What is the reason? The reason is a derives b, and the reason same here, a derives b. So this is the third way of writing this grammar. Now this what we have done here is called as the derivation. So derivation means we start from the start symbol and then we go till the string. Okay, so from the start symbol to the string is called as the derivation. So this whole part is called as the derivation for the string bb. Clear? Now there is one more way to represent this one, is that is we have s tends to a A, that means A are the children of S, and then I have opened this A first. What I have opened? I have substituted B for this A, so I'll write B here, clear? And then I have opened this one as B, so again I'll write B here. So this is the string. We read from the left towards the right, so the string that we'll get is B, B, clear? So we read from this side and go towards this side. So this is called as the parse tree. What is it? It is called as the parse tree. So this is the derivation for the string BB. This is the parse tree for the string BB. And these are the different ways of representation of the grammar. This one, and this one. Now let's see one more example. So we have one more language, that is L2. So the language contains set of all possible strings over the alphabet AB of length 3 that starts and ends with A. So how many words are possible in this case? So it says that the string should start and end with A. Okay. So what I can have A, B, A, or we can have A, A, A. So only two words are possible in this particular language. So A, B, A and A. So this is again, since the number of words are known, so that is why it is a finite language. So what is the grammar for this particular language? So again, we have different ways of writing the grammar. The first way will be S tends to A, B, A slash A. So that is one method of writing the grammar. Now second method is I'll write the regular expression for this particular language. So L2 is equal to, we have A, B, A plus A. So what do? We only write the plus in between. That means the strings we have is either A, B, A or A. So for or, we use plus operator in regular expressions that we already know. Clear? So we have the expression as ABA plus AAA. So what will I do now? I can take this A common from this one. Clear? So let's take A common. So I'll take this A common. So what I'll be left with? I'll be left with BA plus this A is gone, AA. Now you see, again we can take this A common. Clear? Now when I take this A common, since this A is onto the right hand side, therefore this A should go on to the right hand side. Since it's a regular expression, not a simple mathematics, so this A should go on to the right hand side. If it would have been a simple maths, then A should have come here. But it is not a mathematics problem, it is a regular expression. So this A will go towards the right hand side. That is the difference between the mathematics and this regular expression. So what will I do again? This A is here. Then I have taken this A common, this A as common. So this A is on the right hand side. So what I'll be left with? B plus A, this B plus A, and outside what we have? A. So the regular expression that I have is A, B plus A into A. What does that mean? That means the string will be having three parts. First part will be A, last part will be A, and in between will be having either A or B. That you can see in this one. First part is A, last part is A, in between either I have B or I have A. So this is the regular expression for this particular language. Now let's see how we can write the grammar for this one. So grammar will be, it's very simple. S tends to, what will I do? If I say this one as A, clear? So what do I have here? So S tends to A, and then what do we have? Capital A, and then what do we have? Small a. So I'll write small a, and then I'll derive A also. So with A, what I'm getting? Either A or B. So it will be A slash B. So this is the grammar for this particular language. Now let's see whether we can generate this language from this grammar or not. So let's see. We know that we'll start from the start symbol only. So S tends to A. And then what do I want? I want this B in between. So A derives B. So what will I put here? A, B, A. Why? Because A derives B. So this is the grammar for this particular language. Okay, so now let's move on to the case number 2. Case number 2 is for the infinite languages. So we have infinite languages, and the alphabets that I have is A and B only. So let's take one more example that is for infinite languages. So say L3. So in L3, what do we have? We have A to the power n, B to the power n, where n is greater than equal to 0. So this is the language we have. Now what does this A and B n means? This means that every string should start with A and it should end with B. Clear? And the number of A's should be kept equal to the number of B's. Now, the value of n is greater than equal to 0. So, if the value of n is equal to 0, so if I put 0 here, what will I get? I'll get a epsilon. So, I'll get an epsilon here. That means a null string will be getting in case of n is equal to 0. Now, what if I put n is equal to 1? So, if I put n is equal to 1, I'll be getting AB. That means A1, B1. Similarly, if I put n is equal to 2, so I'll be getting AA, BB. Similarly, if I put n is equal to 3, I'll be getting triple A and triple B, and so on. So since the maximum possible strings is unknown in this case, that is why this language will be a infinite language. So we have to design a grammar for this infinite language where every string should be either empty, or if the string starts with A, it should end with B, and the number of A's should be kept equal to the number of B's. Number of A's should be equal to number of B's. Now let's see how do we do this. So first string that I have is epsilon. So I'll derive this epsilon from the start symbol. So one string I have got is null here. So I'll just write the strings that I'm getting here. So S derives null. I've got my one production rule now. Clear? Now, if you analyze this one, you see here that in every string we are getting AB. In the first string I'm getting AB. Second string again I'm getting AB. Third string I'm again getting AB. You can see that this AB is getting repeated again and again. So what if I just derives S with AB? Okay, so that means S is deriving now AB as a string. Now every time in between A and B, one AB is coming. You see here, A and B, one AB is coming here. So every time you can see here that between AB, we have AB. Again, we have AB. So what I can do, whenever we have to repeat this value, what I'll do, I'll just put this variable here in between. So if this has to be repeated in between, then this S should go here in between of AB only. So what I'll do, I'll just simply write ASB. So I have got two productions, S tends to null and then S tends to ASB. Now let's see whether we can derive this particular string from these rules or not. So what we have, I'll use this rule only. So S tends to ASB. Then what I'll do, I need triple A and triple B. So what will I do? In this S, I'll again put this value. So what I'll get A, again ASB, then B. Why? Because S derives ASB. Okay, what I want triple A and triple B. Again, I'll put ASB in this S. So what I'll write triple A and then S and then triple B. Now what I want the string in the form of A's and the B's only. So I should get rid of this S. So how will I get rid? I'll get rid with the help of this particular production rule. So what I'll put here, triple A epsilon and then triple B. So this epsilon can go directly. So I'll get triple A triple B. So this is the derivation for the string triple A triple B, and this is my grammar equivalent to this particular language L3. Now let's take one more example for the infinite languages. So we have one more language, that is say L4. This is the language we have, that is we have to generate all the possible combinations of A and B including null over the alphabet A, B. So this can be written as A plus B star. Clear? This star is called as the clean closure. That means all the possible combinations of A or B including null. Okay, so now let's see. We have this A plus B star. What does that mean? That means the string will contain A or B and it will be I mean to the power of anything. It can be 0 also, it can be 1 also, it can be 2 also, it can be 3 also. That means the string will be either starting from A or the strings will be either starting from B. So I'll write rules for both the type of string. So first of all, since we have to generate all the possible strings including null, so that means S derives null. That is my first thing. So first rule I've got is S derives null. The second thing is the string will be either starting from A or it will be starting from B. So what I'll write, S tends to A and then slash S tends to B. So now I told you in the previous example that whenever we have to repeat anything, so what do I do? Now since S derives A or B, then on this in this string, what I can have, on this place I can have either A or B. Similarly here on this right hand side I can have either A or B. So that means this, since S derives A or B both, therefore I can just simply put S here, similarly S here. Clear? So I can use both of these rules and I can generate any particular string using these rules. Let's see how we can do this. Suppose the string that we have is say A, B, A, B, A, B. So whether we can derive this A, B, A, B, A, B from these rules or not. Let's see how we can do this. So what we have, the starting letter is A we have. So I'll use this rule. So I'll be using this one. S tends to what we have, A, S. Clear? Now again what I have this B, so I'll use this rule. So in this one I'll put BS, that is BS. So I'm opening this one and this is BS, and here I can write the reason also, that is because this S derives BS. Okay, now AB I have got, again next one is A I need. So what will I do here? A, B, on this S I can just simply put this value, that means A, S. Why? I can just write the reason here, because S derives A, S. Clear? Now A, B, A is complete, next one is B. So I'll use this rule, that means A, B, A, then again B, S. Clear? So why? I can write the reason here. Next one is I want again A, so I'll use this rule again. So I'll write A, B, A, B, A, S. Clear? Now for this S, what I can have is B, S. I need this B, so therefore I can just use this particular rule. So I'll be getting A, B, A, B, A, B, S. Now I should get rid of this S. So how will I get rid? I'll get rid from this production rule. So I can just directly put A, B, A, B, A, B, epsilon. What does that mean? That means it is A, B, A, B, A, B. Here I can just simply write the reason, S derives null. Clear? So this is the derivation for the string A, B, A, B, A, B. And this is the particular grammar for this language. Thank you so much.